Do you know how many data types are there in Python? Do you know the basic list manipulations possible in Python? Do you know how to use a list as a stack or queue in Python? Do you know how to create list using loops in Python? Stay tuned till the end of the video to know all the answers.
Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will explore the different data structure available in Python. Next, we will start with the first data structure, that is list. Go to its basics like appending, slicing, and making a list void. Next, we will continue the basics with element count, reversing, sorting, and pop operation. Next, we still continue with the basics with removal of an element, pop of an element, insertion. Next, we will further go deeper in the basics and use list as a stack. Next, we will go further deeper in the basics and use the list as a queue. Next, we will create the list using the loops. That is, we will do the generation of the loops. That is, we'll do the generation of the list using the loops. Next, we will explore the delete, that is the del, and the length, that is len command, which can be used for a list to delete elements and finding out the length of a list. So that's the menu for today. Without any further delay, let's begin. Data structure in Python. We all know about the data structure. In case you have learned C or you have learned Perl, you might have came across different type of data structures in them. Also, we have a series integral. There also we have a data structure. So for each and every programming language, which are very advanced nowadays, like Python, Tcl, Perl, etc., we have inbuilt data structures. That means we do not have to create it. That means we do not have to create the basic structure of a data structure, but we can use the data structure which are predefined in the programming language. So in Python, we have our data structure divided into 4 different sections. First one is list, second one is tuple, third one is set, and the fourth one is dictionary. So in today's episode, we will talk about the list, and in the upcoming episodes, one by one, we will cover the rest. So today we'll focus on the list. We are done here with the slide. Let's move on to the next slide. List basics, that is appending, slicing, and voiding a list. So here goes our Python code. Since in this series we are explaining or learning things through explicit examples. So here goes our first example. The first line is hashbang user bin python 3. It's the interpreter. Next, we have numbers, and here we have a list. So list, you can see, is denoted by the third bracket starting and ending, and in between we have comma separated values. So this will make a list. Next, we can print the numbers, and here we are putting the 0th index. That means 0th index element is 1. So this will print the 1. Next, we will print the numbers with the negative index, that is -1. So from the right side this will count, and -1 should print 9. Next, we have the print, then numbers, then -3. So from right hand side we will have -3, and then we have a colon. So this is called slicing method. We will explain it later. We can add elements to our existing list like this. So we have numbers, they is equal to numbers, plus we have a unnamed list, that is this one. So up to this we had element 1 to 9, and then we have elements 10 to 15. So these all are getting appended here in the list. So this list will become bigger here. Next, we print the numbers again to get the output. Don't worry, we will show the output very shortly as soon as we finish the code here. Next, we have the length calculation, that is the len, and then numbers. So this will determine the how many members are there inside a list, or how many elements are there inside the list. So len operator will do that. So numbers.append. So since this is an object oriented language, we are using append method to append 16. That means here we have up to 15, and then we add this 16 at the last of this particular list. So you can see appending is done. Then we again print the entire list. Now we are slicing the list. One thing you have to remember, that the slicing here is a non-destructive slicing. That means when we slice something, it doesn't actually cut out, but it gives a segment of the entire list. So here we start with the second index and the slicing will end at 5, fifth, right? So 0, 1, 2. So it will start here and 3, 4, 5. So it will end here. So the slice will contain these numbers. So this is called slice. Okay, so and in the same command we are printing it, so we will get the slice. We can do the destructive slicing by deleting the slice. So we can do what? We have the numbers 2 to 5 and we give a empty list here. This will delete the slice. That means this slice will be deleted. So this is destructive slicing. Former one, this one was non-destructive slicing. This one is a destructive slicing. That means it will destroy the elements from 2 to 5 of index. Next, we print the numbers. Further, we have our slice, so making the entire list void from beginning to end. We are making this, so this will create a void. So you can see we are here voiding. So we had slicing, we had appending, and we had void here. Next we print numbers, and finally what we do, we get the output once we run this particular code. So you can see the first print is the 0th element. It gives 1, which is here. Then we print number 1. As I said, from right hand side we will go backwards. So here we have -3, right? So from right hand side we will have 3 elements, that is 7, 8, 9. So you can see 7, 8, 9 is here, and as we add these the list become bigger. Okay, so next we have the length of the numbers, that is 15 is the len operator gives this. We have append, right? So append, add 16 here. You can see 16 is getting added here. So this is the output from our terminal where we have executed this code. So here the slicing 2 to 5 non-destructive slicing is 3, 4, 5. That means 2, 3, 4. So this one 3, 4, 5. So 3, 4, 5 gives this one. And as we delete this slice, that means we will delete these numbers. That means 3, 4, 5. If we delete it, what it becomes? It shrinks, and you can see this is the destructive slicing. So destructive slicing actually deletes the element and shortens the list. So here we have done the voiding here, right? And hence once we print it, it is coming as a void list. That means all of these numbers have vanished because of this void operation. So these are few basic list operation that you can do with the list, and you know the syntax of the list is how it looks, as we have explicitly exemplified here. So we are done here. Let's move on to the next slide. Now we will further discuss more basic things like element count, reversing, sorting, popping. So here goes our code. The first line, as usual, the Python interpreter, that is Python 3 interpreter. Next we have the list with orange, apple, all these fruits are there. Next, so here we are writing apple count, that fruits dot count, then apple. So number of entries here. Okay, how many apples are there? So you can see apple is here and apple is here, so it will be 2. Grape count is fruit dot count, then grape. So number of entries, how many grapes are there? So there is no grape here. Okay, so it should be 0. Next we have pear index, and here we are using fruit dot index and then pear. Okay, so pear, how many pear are there? 1 pear is there, so it will be 1. Next, banana index after 4. So after crossing 4 elements from the beginning, how many entries of banana are there? Okay, so here we write banana then comma 4. So that means after 4 elements are crossed, how many bananas are there? Next we have the reversing operation. So here the reversing operation, how it is done? So we have the list, we simply add the reverse method here. So we write fruit dot reverse, and it will reverse the entire list here. So this list will be reversed. So banana will come first and orange will go at the end, and similarly this will come at the second, this will go here, like that. Reversing will happen. Next we have the print fruits. We print this thing. Next we have the append operation, and we add grape. So grape, you can see it was not here, so we added grape, added, and last element, use the append method here to add it at the last. Next we print the fruits. Okay, and then we write the fruits dot sort. So it will do the sorting. That means it will sort among all the names. Then we write the sorted list, and then we give the fruits, and then we have print popped element, then fruit dot pop. If we do a pop operation on the list, okay, using the pop method, what element comes out? As we run the code, it comes like that. So you can see at the last we had added the peer, right? So let us go one by one from the beginning. So here you can see apple count. Here it is 2 because there are 2 apple, right? Grape count is 0 as there was no grape. Peer index, so it is not count, it's an index, that means the position is 2, so it gives the index. Banana after index, that is the position here, it's index, and here we have 6. So this is not giving how many bananas, rather than it is giving the index. So this is the index and this is the count, so that is the difference, right? So earlier I have just misread it, and so misinterpretation was there, sorry for that. And here you can see the index, right? Index means what is the index of it. And here we can append grape. So as we append grape, the grape comes here, okay? And you can see here the reverse is there. So what happens? The entire this list is reversed here. So banana goes at first, then apple goes here, then kiwi goes here, then banana goes here, and then pear goes here, and apple goes here, and orange goes here. So this is how the reversing is done. Reversed is done, then we have the sort operation, and then we have printed. So sorted is this one. So you can see there is a basic difference between this and this. This is how the things are sorted. So you can see A, B, B, G, K, O, P. So it's in alphabetical order. So they are sorted in the alphabetical order. And then popped element, whatever we pop, what comes here? At last there was peer, right? So the last one is popped out. So popping means we opposite to the appending. So here we have append, right? Append operation, the exact opposite of the append operation is pop. So these are two mutually opposite operations. So whatever you do as append, if you pop it, it will come out. So here we are done with the code example and its output and the explanation and the mapping. Let's move on to the next slide. List basics, removal, pop, insertion. So let us start our code to get the taste of removal, pop and insertion. Now here starts our code. First line is hashbang user bin python 3, that is the Python interpreter. Next we have our list where all fruits are there and totally removed by name. So first let the removal operation begin. Okay, fruits, then remove, then peer. So we can remove peer from here. Peer is here, so this will be removed. Next we print the fruits. As soon as we run the code, we'll have an output and we'll compare. Wait for that. Let us finish the code. Pop out by index. The fruits pop, then we give the index 3. So that means the third index 0, 1, 2, 3. So this means this one will be popped out. Next we print it and then insert again and in the desired position. Okay, so fruits dot insert at the third position is watermelon. Third watermelon was not there, so at the third position we entered watermelon. We print the fruit. So now once we run the code, this is the output. You can see once we remove the pear goes out. Pear is not here. Pear earlier was after the apple and before the banana, so it is vanished. Next one is the pop 3 operation. That means pop of the third one. So pop of the third one means 0, 1, 2, 3. So kiwi vanishes. So you can see the kiwi has vanished here. And here you can see the insert at the third position is watermelon. So 0, 1, 2, 3. So at the third position, watermelon comes again at the place of the kiwi. Earlier kiwi was here and now it is replaced by watermelon. But what we have done, first we have popped out, then we have inserted. Okay. So this way we have done the operations. So we're done here with the examples and its explanations and the code execution. Now let us move on to the next slide. List basics, use it as a stack. So in this example, we will use the list as stack, and let us begin here. The first line of the code is the Python interpreter. Next, we have defined how the stack is working. So using the list as a stack, and we use the method last in first out, that is LIFO, L-I-F-O. LIFO is the method of the stack. Stack you might have read in case you have microprocessor in your syllabus. So there the stack is there. In case you have not, you will use this example to learn how a stacking operation done in the programming or in the data structure rather than inside the data structure through the programming. First, we have stack defined as a list, and here it is 3, 4, 5. So we will operate it as a stack, not as a list. So what we'll do? First we append 6, that means 6 will get added here, okay, and then we append 7, so again 7 will get appended at here. Then we print the stack. Next we write stack.pop, that means 7 will be popped out, and then again we write print the stack, and then we write again stack pop. So that means in this pop operation 6 will be out, and again we print the stack. Once we run this code, here we have done the two appending here, right? 6 and 7, 6 and 7. So next, once we pop out, right, the 7 is gone. 7 you can see is gone here, and the next operation you can see the 6 is gone here. So again it comes back to the original state. So this way we can use the list as a stack. So this can be a good interview question. You might have to memorize this example, okay, the code example for your interview, and from here you can answer the questions. Here we are done with this code example and its output and the explanation. So let's move on to the next slide. List basics, use it as a queue. First line of the code is nothing but the Python interpreter. Let us see how Python list can be used as a queue. So using list as a queue means first in first out, that is FIFO, F-I-F-O, FIFO, first in first out. Stack was LIFO, that is last in first out, and queue is first in first out. So here goes our first line of code, that is from collections import dq. So we have a module called collection. Inside that we have a method called dq. So we are importing dq from the collections library. Next we have q is equal to dq Eric, John, Michael. So it is a list and we are using the dq operation on it. Next we print the queue. So this has made a queue, right? The queue operation, queue is there, which is a first in first out operation. We have converted this list with this command into a queue. Okay. Next we will use the queue means queue.append. So we will have use the append method, then we write Terry. So Terry arrives. Okay. Next we print the queue. Next queue.append, then Graham arrives. Next we print the queue, then queue, then pop left, Eric lives. So here we have done the appending, that is in, that is the first in, right, and then pop left. So from left side it will pop. So the first one, Eric, is removed by this one. Next we print the queue, and next again we do the queue.pop left. That means after this John will go out. So John leaves it from this queue. And we print the queue. So let us run the code, and once we run the code we get this output. So this is dq is a queue, right? So here it is printed as is. Now as we append Terry, Terry comes after this Michael, right, and Graham is this. Now this was the first one entered, so this has to go first, right, Eric. So as we do the pop left operation, the Eric vanishes here, and next we would do the queue, the John vanishes here. So John was here present and he removes and he leaves, or the element is getting removed. This way the list in Python can be used as a queue. And one thing, remember, we have to use this particular thing. That means we have to use the dq method from collections. Here we are done with the code and the example and its explanation. Let's move on to the next slide. List generation or list creation using loops. Loops, we know, that is the for loop, while loop, all these are loops. So using the loops, how we can create a list. First goes our first line of code, that is Python 3, and then we have the squares. This is nothing but a list, but it is empty, you can see. Then we have a for loop with the range operator for x in range 10. So that means it will start from 1 and it will go up to 10 as an integer with the increment, and the for loop will rotate for this. What we do? We write squares.append, then x to the power 2. Okay, so we are using the power operator using double star. Next we write the print, then square. So here as we come out of the for loop, we write it square. How we are coming up the for loop? Because you can see the indentation, whatever inside this indentation will be in the for loop, and as we come back to this original indentation, that means we are out of the for loop. So this is the convention in Python, which is very different from any other language. Next we have another list, that is comps, that is also empty. We write for x in 1 2 3. So it is a complete list and on which we will operate x, and that means x will be first 1, then 2, then 3. Using that, and here we write for y in 3 1 4. So there is another list. Y will operate like that. We write if x not equal to y, then comps.append, then x comma y. This is a kind of coordinate like structure, that is x comma y. and then we print the comps. So let us run the code and see the output. What happens? The first one is x, that is range 10, that is it will start from 0, and here it is with 81 because it is doing the squares, right? So 0 to the power 2 is 0, then 1, then 4, then 9, then 16, and this way it goes up to 9, which is the 9 square is 81. And here you can see that we have done the comps, that is the combinations, right, for x and y combinations, and where x is not equal to y, that means this one and this one will not work, and this 3 and this 3 will not work. So apart from this, all other xy combinations, that is the coordinates like that structure, are kept here. So this is the first element, which is again combination of 1 and 3. This is the second, this is the third, this is the fourth, fifth, sixth, and seventh. This way the lists can be created using the loops. So we are done here with the code example, its explanation and the output. So let's move on to the next slide. The del and len command. The del means the deletion command, that is the delete command, and the len means the length command. So we have seen this, but we'll explicitly cover examples here about these two. The first one, as usual, is the Python interpreter. Next, we have the list of fruits. So there are several fruits here, and we write del, then we write a slice, that is 2 to 3, that means 0, 1, 2. That means 2 to 3 will go for deletion. So we'll del this particular slice. So this is a destructive slicing. Next we have fruits, print then fruits, then length of the fruits, that means length of the remaining elements after the deletion will be printed here. Then we write del fruit 0, the 0th index is deleted. So del can be used to delete a slice, or del can be used to delete one particular element. Then again we write fruit, then len, then fruit. So we will print the fruit as well as its length. So you will see both the things coming out as an output. Once we run the code, we have this output. So you can see after we deleted 2 to 3, what happens, that orange is appear there, and then from peer, that means the 2th element, up to it, this only is vanished because there is no more, because banana is here, right? So banana is here, kiwi is here, apple is here, banana is here, again apple is here, and orange is here. So by this deletion, right, peer goes out of it. That means the peer is deleted from the list. And next, as we have deleted the 0, that means the orange is deleted and the apple shifts this side and comes here. So you can see orange is deleted by the del command. Okay, this is the simple use of the del and the len command. And length, you can see here the length output is 6 here because there are 6 elements, and here it is the 5 because here the len at the last. So first is fruits. Fruits is covering this area. Okay, the list. Len is getting printed here. Similarly, the fruits is here up to this, and the length is 5. Length is 5 here, you can see. So this way the del and len command can be used along with the list. We are done here. Let us move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below. And bye for today.